Now we are using it in different bands and different parameters we are using to change the interpretation of objects on the Earth surface. So the one classification, if we look at from the radiation we receive from the sun. So the sun light is composed of many bands here. This is visible band. This is visible band RGB, red, green, and blue. And then if we go on to the left side, then I was explaining to you that there are UV, X-rays, and gamma rays. They are being used by the medical fraternity for their different uses. And these are not much in use in the remote sensing. The things, the bands, or you can say wavelength, which are lesser than the 1 micrometer or say 0.1 micrometer, they are not being used in the remote sensing. On to the right, when we go right of this visible band, then we find that it is near infrared, mid infrared, far infrared, then comes the microwave, and then comes the radio, and then the TV bands. So when we listen to radio, then the frequency received by the radio is in this range, which is higher than the microwave, and microwave ranges from 1 millimeter to 1 meter. So you should remember it. There is a trick to remember all these wavelength, is that this is 0.4 to 0.7. Visible band is 0.4 to 0.7 micrometer, and microwave is 1 millimeter to 1 meter. 1 millimeter to 1 meter. Now your radio wave starts from here and it goes on different bands of the radio band. Radio bands, audio band, and then TV. TV, the energy is being transferred from this side here. Radio and TV bands are this side. So we mostly use the visible and the near infrared and far infrared for the remote sensing, depending upon the transmission from the atmosphere. Last time I explained you that a lot of energy is getting absorbed by the atmosphere, particulate matters. The pollution in the atmosphere interact with the energy emitted by the sun, and not all the energy is reaching or falling or striking onto the objects. So if the energy is not striking on the object, how would that energy would be reflected? So reflection is taking, or reflection takes place only of the energy which is incident on the object, So this visible energy, then the infrared, then the microwave, and these are called different bands of the sunlight, or you can say electromagnetic radiation, different bands. And most of the remote sensing, this is passive remote sensing, the energy which is getting we get from the sun, EMR of the sun. When we use this in the remote sensing process technology, then that kind of remote sensing is passive, and in this, these are the bands. And accordingly, this remote sensing may be the microwave remote sensing, infrared remote sensing, or remote sensing done in the visible range is called. I show you further slides. We have discussed this last time, the transmittance of the energy through the atmosphere, that how much energy is being transmitted onto through the atmosphere onto the object on Earth's surface. So here transmission is null. Here transmittance onto y-axis, you look at 0%, then 50%, 100% transmittance. Means whatever is being emitted by the sun is reaching onto the Earth's surface. Now, some of the bands, like here you look at 0.2, means visible starts here, 0.3, here visible it starts from here, 0.3 onwards, and then infrared, then here comes the microwave band. This is 1 millimeter wavelength to 1 meter somewhere here. This is microwave, and beyond that are the radio waves here, and then the TV, and onto this side are the X-ray, UV, and cosmic rays. So we are least bothered for the remote sensing. We are interested in this much wavelength, these wavelengths of the electromagnetic radiation of the sun. And within this, here this portion is not transmitting. Most of the energy is being absorbed by the atmosphere. Here also you look at most of the energy is absorbed. If you do energy capturing through sensors in this band, then there won't be any capturing. So here also no transmittance. And in this you look at from one micrometer to 1 millimeter. This is 1 millimeter is the starting of the microwave. So here also there is hardly any transmittance from the atmosphere. So there is no use of this energy. This energy is getting absorbed in the atmosphere. So most of the remote sensing is done this area, and this is important microwave bands. And these Ku, Ka, X, C, S, L, P. These are the bands of microwave this radiation. These are different bands defined. If we are selecting say 10 millimeter, then that band is called K, and if we are going towards 1 meter, then it is P band. In the previous slide, you look at that microwave energy is taken here 1 millimeter to 1 meter. But here the radar is written, you look at where we are going from almost 1 centimeter onwards and it is crossing 1 meter. Radar is crossing 1 meter. So radar means this is active energy being emitted by the radar to capture back and carry out the remote sensing activities. So radar is not the energy band of the sun, but it is just for the sake of understanding that microwave we use, this is also part of microwave wave, and beyond that we do. And in the next slide you will find that we are having here the transmittance. So there would be lot of reflectance, and reflectance is only what we are interested in. That reflected amount of energy give us notion, give us interpretation of the objects on the earth surface. And through the remote sensing, we are interested in that where the mountains are, where the valley is, where the forest is, because we want to do many civil engineering projects, say DMIC, Delhi Mumbai Industrial Corridor. There is lot of money being invested. So this is long, say 1,000 kilometer long corridor, and what they are developing many industrial estates, many highways, many railway tracks. So we need to do a kind of aerial survey or kind of say quick survey. So this conventional survey that manually going onto the site and checking everything is not possible at initial stage. For a smaller area that can be done when we are actually constructing, then the actual work is done with the instrument for the smaller areas. When we are taking out the feasibility report, whether DMIC is feasible or not, whether we could run this through these lands, then preliminary reports could be prepared instantly within few weeks of time. Can be like surveillance system in the Galwan Valley or onto the frontier LAC or LOC is also, those areas are also interpreted through the remote sensing images, that which area is occupied by the defense forces of India and of the China. So that kind of thing can be interpreted. We can't do really say aerial photogrammetry. That is not permitted to take the aircraft at so low altitude to capture the information on the territory beyond the LACs. So these satellites are of some use for us to really capture the information and then interpret in terms of the occupation. The concept I have given you of the transmission windows, that this slide is basically previous slide, almost previous slide, but we call these as atmospheric windows. Here this window is closed, this is closed. I have explained in the previous slide that there is no transmittance from the atmosphere and the energy will be absorbed. So where there is a transmission, so this appears like a window, that it is opened up and energy can move, can be transmitted. So these are called atmospheric transmission windows. So there are many times a question in GTU of 3-4 marks that write about atmospheric transmission windows. Then you need to explain this, draw a almost a sketch of this at least with the wavelength mentioned. And if these lines are not exactly, but you could reproduce somehow something, and if you show that there is no transmittance here and there is heavy transmittance here, then this sketch should be drawn by you freehand in the examination to reproduce these transmittance levels and to explain that what the transmission windows are. This is just a kind of understanding to make the thing more clearer in your mind, that each type of molecule has its own set of absorption bands that different molecule absorb differently. Various parts of the electromagnetic spectrum. As a result, only the wavelength regions outside the main absorption band of the atmospheric gases can be used for remote sensing. These regions are known as atmospheric transmission windows. That is what I explained to you. Now, this chart is very interesting to understand the initial level of remote sensing, because this will give you a kind of understanding that how we really differentiate between different objects on the Earth's surface. In the photograph, instantly we come to know, when you say capture a photograph, then in photograph whatever appears to you, you could visually distinguish different object in the photograph. Like there is a building, a car, a road, or another thing on the photograph, you could say, because it is a continuous analog picture. But here in this remote sensing, what we capture is energy, reflected energy. And that is not a photograph. Photograph, we process this energy and then we create the photographs, we create the maps after processing. So that is big change of thing, that this is a digital thing. Here we capture energy. Captured energy is converted into different objects. Energy is converted into object. Now these are the objects. One is object is soil. Look at this chart. Soil, second is vegetation, and third is water. We have captured a remote sensing image. In remote sensing, whatever energy is captured onto the sensor in form of energy is called image, because that is a pixel wise storage of the energy. Pixel wise storage of the energy. Pixel, I would explain you at a later stage what is the pixel, that where the energy is getting stored. Now here there are three objects on the Earth's surface. One is soil, second is vegetation, third is water. And here onto the x-axis we have different light bands, different EMR spectral region bands, which is blue, green, and red. This is visible. This is near infrared and this is mid infrared. You could say 0.4 to something below 1 millimeter wavelength of the sun energy. So between this energy level wavelength, the spectral reflectance means how much energy being reflected by the objects. So different object reflect energy differently. If I take soil first, if I consider soil, then soil means this is barren land. Soil means soil is barren, only soil is there. There is no tree, no building, no road, no car, nothing, only soil on which the energy is falling or light is falling, and reflected energy is being absorbed, or reflected energy is being recorded by or onto the sensor. Then how much is the reflected energy? In blue band, soil would reflect very less. In green band, a little more. In red, little more. And the soil reflect energy very much in high energy reflected in near infrared and mid infrared. So when we are interested more in soil part, say for agricultural use, when we are more interested in soil part, say we want to distinguish with different type of soils, then soil is a very good reflective material. In which band? Near infrared and mid infrared. So different material, different object onto the Earth's surface, they reflect in different wave and different bands differently. Here, if I take vegetation, look at vegetation. Vegetation, blue, it does not reflect much. Green, vegetation in green band reflect very high compared to blue and red. But if you go in near infrared and mid infrared range bands, then there is good reflectance. So for vegetation, if you want to identify a kind of forest it is, and there are different trees, then you should do what? Which kind of remote sensing? The infrared remote sensing. You should carry out your remote sensing in infrared bands. Likewise, if I want, I'm more concerned about the water and different water bodies, water resources available onto the surface, and moisture level. Water means moisture level, or even turbid water, or shallow water, or ocean, like sea, ocean. So if I want to do certain kind of remote sensing, if you want to analyze those data about the water, then the water reflect much in this visible range. You look here and list in red, and minimum in near infrared and mid infrared. So looking at the object we want to interpret, we have to use accordingly band, because they have different reflectance values. I think you understood this. And I go further. If you are not getting my point, you keep writing on piece of paper, and at a later stage, I would answer your questions. I have explained this, but you read this, that what these are. Here, I have explained you two types of remote sensing: passive remote sensing and active remote sensing. In passive remote sensing, I have explained that if the energy source is sun, then the kind of remote sensing it is called is passive. If we have our own sense, this if we have our own source of energy, then it is active remote sensing. Makes use of sensors that detect the reflected or emitted electromagnetic radiation from the natural sources, that is mostly sun. The second passive remote sensing, you could say thermal. Thermal, we have not seen the spectrum earlier. Thermal is not covered there onto that, but that is not the artificial. Here, active remote sensing, this makes use of sensors that detect reflected responses from the objects that are irradiated. Irradiated is technical term, means radiation which is falling onto the objects, and then the radiation reflected. Irradiated means the radiation going back into the atmosphere and reaching to the sensors. So detected reflected responses from the object that are irradiated from artificially generated energy sources such as radar. So I assume these two definitions you are becoming comfortable with the passive remote sensing and active remote sensing, that the use of one type of sensor, second type of sensors, there is always reflected energy onto the board, but which we are capturing is more important. That's why the word sensor is used here. Sensor is used here. So this passive remote sensing makes use of sensors. Sensors we install. Through sensors, we capture the reflected or irradiated energy. So might be more clearer in your mind now. One more kind of classification, very interesting. That's why I kept it here. Based on wavelength reasons, remote sensing is categorized as visible and reflective infrared remote sensing. If we do visible band, then thermal infrared remote sensing, then microwave remote sensing. You could also classify types of remote sensing. Earlier we done this upon the energy source and the sensor we use, active sensors or passive sensors. Here we use the band to define the remote sensing. So just take note of this, that we could define this differently. Earlier, I have shown you the major components. Now I am elaborating on this, the energy source. Then the platforms. Look at this. I show you this type and now. Okay. Are you looking at 15th number slide, all the students?
Yes, sir.
Yes, sir.
I'm elaborating a little more on the different steps, elements of remote sensing, giving you a visual interpretation of different components involved in all the 6-7 steps I have shown you in second slide. This is energy source, this sun or say radar. Then the components is platform. Platform vehicle to carry the sensor. Sensor is what it can be: aircraft, space shuttle, or the satellite. Even you can say a big balloon, hot air balloon could be like a vehicle, or anything on which the sensors are mounted. But mostly for the sake of this, in ordinary way, we say the aircrafts are used, space shuttles are used, and definitely remote sensing satellites are used. These are called vehicles which carry the sensor in the space to capture this. So these are the platform. So platform here, if you look at, then they sense from 1 meter to 36,000 kilometer height. This 36,000 kilometer, you look at differentiating point, the airplane, the altitude of here aeroplane is 36,000 feet. When you do the air travel, when you go from here to say Bombay or Bombay to London, then while traveling through the flight, your altitude is around 36,000 feet. But here these are the satellites. The satellite altitude from the Earth's surface, this is Earth's surface where you are standing over here somewhere. If you capture here the data through this sensor, this is camera is also a sensor, your eyes are also sensor. If you capture something, say here some work is going on, you take a photograph, then this capturing of data is nothing but remote sensing, but here it is 1 meter only. But here the satellite here, major satellite are like they are having very high altitude. All the remote sensing are not at that altitude. That is, they are at around 800 kilometer or say 1,000 kilometer. But uh, some of the satellites are as high as 36,000 kilometer of altitude. So your platform remote sensing is this much. This is just for understanding. We are not going to do research or something like that, but we should make up our mind to understand remote sensing. When low altitude data is taken, this is low altitude, almost all the Indian remote sensing satellites, there are 13, 14 satellites launched by Indian government to capture the data of whole Earth surface, covering most of the Indian territory as well as of the neighboring areas. And Indian remote sensing satellite system is considered one of the best in world. And we do sell these remote sensing pictures, images to other countries, and we earn revenue. We earn money out of this technology. We are highly developed. India is highly developed in terms of platform, in terms of remote sensing technology and its processing. So 1 meter to 36,000 ground-based platforms, airborne platforms, and space form. So platform is nothing but you could say carrier of the sensor in the. Then sensors, the sensing device to detect electromagnetic radiation or irradiation, reflected from the surface of the earth back into the space and then capture. So these are the camera and scanners. They are mounted onto platform. So sensors, devices to detect electromagnetic irradiation like camera, sensors, etc. And they are different at different levels. Now I'm giving you a kind of understanding about different sensors. They capture energy irradiated from the Earth's surface. So here, passive sensors are like this. Landsat. These are different sensors launched by different countries. Landsat, Aster, QuickBird, Iconos. These are sensors. We are least bothered for that what the other countries are doing, but for the sake of comparative studies, that and how and uh, how far they are gone into capturing the data and what kind of data can be captured by different sensors invented or produced by different countries. So this Landsat data is Indian. Aster's, QuickBird, Iconos are different countries. QuickBird is American, Iconos is American, Aster is probably German. So these are the sensors of different countries and how they capture data. I'll explain this picture also. So active sensors are LIDAR and radar. These are, you can say, satellites also. Okay. LIDAR and radar, which are gone into the space, they capture the sensors are located on these platforms, and LIDAR and radar are active sensors, and Landsat, Aster, QuickBirds, and Iconos are the passive sensors. Passive sensors means they capture only sun energy, not the active energy. So these are the passive sensors. Now look at these this sketch here onto the right, where two are written passive and third is written as active. So I explain you first the passive remote sensing using reflected. Is it visible? A very small font used here.
Yes, sir. Visible. Zoom करके देखिए कैसे.
Visible. Okay.
Yes, sir. Yes, sir.
Okay. Remote sensing using reflected solar radiation. So solar radiation, here sun is emitting energy falling onto the Earth's surface, and some platform is there in the space, say at some altitude of 1,000 km, and it captures the irradiated energy which is coming from the sun falling onto the Earth's surface, going back to the platform. It captures that energy. Now the second is that the using radiation emitted by the object. Here this energy is reflected. First sketch, you should note it very minutely. In first sketch, the energy was reflected. Here, what is emitted? So emitted is not reflected. Sun is there. It hits all the bodies on the surface of the earth, and heated energy, emit certain kind of radiation, and we call it thermal radiation. So everybody, in one way or some, they are considered as black body and emit radiation. So emittance from the object, this is not reflected. This is only the rays which are falling, and they are shown only for the sake of heating the Earth's surface and different objects on the Earth's surface. So this energy heat, so heat energy absorbed by the different bodies, and when it is in equilibrium, then it emits energy of certain amount, and that emitted thermal energy is captured by the sensors mounted on the platforms. So this remote sensing using radiation emitted by the object. So this is also a passive energy. So I'll end my this session in 2-3 minutes. Don't bother much. So, okay. So here in the third sketch, the active remote sensing, this is the platform. The platform where the sensor is mounted, it emits energy. Sensor does not emit. There are instruments mounted on this platform, separate from the sensors. They emit the energy. They emit the energy which falls onto the object, and that same energy go back into the atmosphere and captured by the sensors mounted onto the platform. So this is active remote sensing. Say your platform is emitting energy and your platform is getting back the reflected energy. So this is active remote sensing. So first two are passive remote sensing. One is reflected, second is emitted, and third one is active remote sensing. And these are two active, and these are the passive remote sensing. This is how the emittance, the middle passive energy, the black body radiation, you have already gone through this in your high school, that how different bodies emit the energy, the thermal energy. So they emit in the band. I have brought this image here because I want to show the wavelength only, the wavelength, that 0.4 to 0.7 is the visible band here somewhere. You look at here somewhere, visible band. 0.7 and beyond, this is thermal energy emission. The thermal energy maximum emitted by the object is in this area only, say 0.4 to something between 0.78. So here, this visible range is mentioned on the top of it. This is infrared, this is UV, and here it is at 0.4 somewhere here. And this is the maximum emittance from the objects is this, and at different temperature of the object, it emits differently. That is also visible to you. So the concept of black body is, if you understand, then the emit energy and this emitted energy can be captured by sensors in one type of passive remote sensing. This is remotely sensed data by the different type of capturing devices, and they are called different also. Aerial photogrammetry, your picture would be like this. Your picture would be like this. I'll show you more comfortably. This is last slide today. I won't show anymore. So this is picture. This is aeroplane taking a flight. Altitude, you know, is a feet around 30,000 to 35,000, 36,000 around altitude, or you can say 10 kilometer only. Your aeroplane above the clouds, it takes flight, altitude is around 10 kilometer. Okay. Let me bring my charger. Just hold on for a second. Okay, I'm comfortable now. I'll take 2 minutes only. So this is multispectral. Multispectral aerial photogrammetry. This is called stereoscopic view. We generate this kind of 3D images in stereo through stereoscopic. And there is one complete chapter in this subject on aerial photogrammetry, and this kind of view or the maps can be generated using two stereoscopic photograph of the area, which are taken by the flight, and when camera is on and we generate this view. Then there are multispectral satellite. Multispectral means this satellite capture the image in different spectral bands, multispectral, different bands, multi-bands you can say. So these give us more clearer view of the area. Then there are radar system. Say radar system, we emit energy and also capture energy through our vehicle, and then this capture is this hyperband, hyperion. So here the number of hyperspectral sensor, I would explain also through more information or hyperspectral sensor and hyperspectral remote sensing. That here there are number of bands, and the information captured is precise and meaningful for different purposes. So this introductory level, we can say that different remote sensing provide us with different set of data with the different set of accuracy levels and for different purposes. if we need more accuracy.